السلام عليكم. لو سمحت الورشة تبدأ الآن.
Hello, everyone. So welcome back from the break. My name is Reem Al-Faleh. I'm a threat intel analyst working at Cypher. And today, inshallah, we're going to talk about automating the validation of phishing sites through the usage of artificial intelligence. Just a quick overview of the things we're going to go over. We're going to first talk about cyber threat intelligence and cybersecurity, and then we're going to go over the problem scope. We're going to talk about artificial intelligence, computer vision, using the artificial intelligence to automate the validation, which is the use case. And then finally, I'm going to give a demo of the script that was written for the use case. At the very end, I'm going to highlight the key takeaways from this session. Okay, so a very common question I get asked is, what is threat intelligence? What do you do when you work? So basically, in cybersecurity, you're either on two sides. You're either on the defensive side or the offensive side. Threat intelligence mainly lies within the blue teaming infrastructure, which is the defensive team. What do? We do damage control, incident response, operational security, threat hunting, and digital forensics. Basically, everything that helps an organization to countermeasure any threats before they happen. Okay, are these all responsibilities fall within the CTI limit? No, we're mainly responsible for gathering, analyzing, interpreting this information about cyber threats that in the wild and that could potentially harm organizational assets, digital assets, data, and reputation. And also, we proactively identify emerging threats, these ones that could be exploitable vulnerabilities, any threats that are targeted towards entities that could be of harm to your organization. We also search for indicators of compromise. We do threat actor attribution. We seek for a threat, and then we aim to attribute that threat to a known threat actor. And by that, we provide actionable intelligence to strengthen the organization's cybersecurity infrastructure. When we talk about digital assets, these are anything that is stored digitally and the organization seeks to protect. These could be such as digital media accounts, any graphics, any directories, any workstations that the organization might have, any websites, anything that an organization values. So CTI, in a nutshell, aims to perform a mapping between the internal focus of the organization, which is basically your assets, elements, your business landscape, and helps to map it with the external focus, which is the threat actors, the attack vectors, any vulnerabilities exploits. By mapping those, we get to identify potential security incidents early, analyze security and impacts of these threats, and potentially provide any proactive measures for the organization. And speaking of threats, Have you ever received anything similar to this email or this text message asking you that, hey, your credentials are needed to be upgraded, or your shipment has arrived, we need your contact information? If you do so and you fell for it, then congratulations, you've been hacked. This scenario is called phishing. What are phishing attacks and how can we break down the infrastructure for the phishing attack? Phishing can happen through emails, through spear phishing, text messages, farming, websites, anything. Here we have a hacker. This hacker is sending you an email, sending you a message or a link that says, enter your credentials, enter your phone number, enter your password. And once you do, without validating the website, you get to fall a victim for this hacker, which will use your credentials and get your maybe withdrawals from your bank account, or can use your accounts with the privileges you have on any social media or any websites. Why is it important? Why are we talking about phishing in particular, not any other cyber threats? Phishing not only affects individuals, it also affects businesses. We're talking about government agencies. These are things critical. We want to protect them and we don't want any harm that could potentially lead to endangering them. Low barrier to entry. As compared to other cyber threats, phishing is considered the lowest skill entry to any point of an organization. Social engineering exploitation. Phishing also again preys on human psychology. This means it exploits your trust with with the organization, your curiosity. Anything that leads you to clicking on that link, it will depend on it. Finally, evolution and sophistication. Attackers constantly elevate their techniques and constantly seek for using automated phishing attacks even nowadays. Okay, here comes our role as CTI analysts in detecting these phishing attacks and mitigating them. We play a crucial role. For example, in my company, we do brand protection. We aim to protect the assets of brand, the logos of the brand. Doing this analysis and going through them one by one takes time and efforts from the CTI analyst that could be spent doing other things. Which brings me to the problem scope of this session, which is the manual validation of phishing sites. Okay, imagine you're a CTI analyst and you receive this page saying, hey, CTI analyst, please receive this phishing page or this page, validate if it's authentic or if it's a fake one. What we will do initially, we will provide initial detection. We will look at the page. We will see, does it have any logo? Does it have any iframes? Does it have any login prompting text? Does it have any buttons, any contextual text that leads to saying that this company is actually, could be a possible phishing attempt? Next, we do the URL analysis. We look at the URL. Is it authentic? Is it real? Is it coming from the exact source or no? And then we aim to do also page source code analysis. This is also to check for any malicious buttons, anything that could be written within the HTML content of the page. And also we do IP address hosting and analysis. This goes through the whois databases to see who's the hosting domain, what's the IP, what's anything related to this website. And also, we do a quick scan of the URL. This is to see how many vendors have marked this domain as malicious and what are any, if anyone has came across this website and potentially marked it as malicious. And also we do a quick URL scan to see the website if you want to interact with it, but not directly. Could see also if anyone has labeled it by saying potentially malicious or harmful. This is considered to be a challenge. The identification of potentially malicious URLs, the human content analysis, and the decision-making process is a challenge and takes so much time from the analyst's time that could be spent doing other things. With that, the amount of emails, the amount of requests from clients asking us to analyze this content is overwhelming. Almost like on a daily basis, we get 5 requests saying, hey, analyze them, which takes, as I've said, time and effort. And so we need a faster and scalable validation. Okay, this fast and scalable validation method proposes the use of artificial intelligence and, in particular, computer vision. Why do I want to use AI in detecting phishing sites and not depending on manual analysis? First, we want to say automation. AI and AI models, they help to automate the detection, analysis, and also reduce the manual effort that falls on CTI analysts. Second is for scalability. Scalability means accommodating vast volumes of data. Instead of me going through 5 sites, I can give it to ChatGPT, I can give it to AI models, and then ask them to do so without compromising the performance of the tool. Third is adaptability, which means that the AI models can adapt to new phishing techniques, as we highlighted earlier on. If the attacker decides to move forward with any advanced methods, AI models can detect and potentially learn from these models. The fourth and last one, which is the reduced false positives. When we talk about false positives, AI models, they are training based. You give them sites and then they train based upon your detection, your techniques in detecting them. You can refine the model and also go back and forth until you reach the desired states. Okay, going into AI models, we want to talk about the bigger umbrella, which is the artificial intelligence. Artificial intelligence helps to make computers smart. We want to use this function in particular to get use from the data and decisions and also solve some problem on their own. Now, machine learning, which is a type or a subset of the artificial intelligence, where computers can learn from examples. We give them examples, we enrich them with data, we enrich them with text, so they can learn from it. Deep learning, which is a deeper subset of artificial intelligence or special kind of machine learning, which depends on neural networks. Here is your trusted ChatGPT model. ChatGPT mainly learns using deep learning and machine learning to illustrate a good example of deep learning. Finally, which is computer vision, what we want to use in this use case. Computer vision, basically, it's your eyes as a computer. Computer vision helps us to take visual context such as images, videos, and analyze them by saying this, I detected a logo, I detected a content, I detected a link, and so on. How can computer vision identify any brand impersonation sites? By first, computer vision analyzes logos, layouts, contextual content, and interactive elements. These include the login forms, any images, any background images that could indicate that this is your brand. Second, it compares these elements with known ones. These known ones are a known database of legitimate websites. And then computer vision will give you alerts saying this is a potential scam, and you can go through it quickly. Okay, computer vision on its own will not work in this use case, so we decided to incorporate a headless browser. What's a headless browser? It's basically just your Google without a graphical user interface. So imagine this is a website that has everything aligned perfectly. You can see the text, you can see the date, you can see the design of the page, the colors. A headless browser would give you the exact same without any of those. It would give you only the HTML content and the text itself rather than the graphical user interface of the page. Why do we want that? We want to be able to navigate to the malicious website and then take a screenshot of the content and then bring it to AI for further analysis. Okay, it will do that on 3 stages. The first one is the phishing site detection. In a combination of headless browser and computer vision, a headless browser will navigate to the suspicious URL and then through various means such as email links or messages or user-reported sites. And then the computer vision will analyze the content that has been brought by the headless browser. It will look for any signs of phishing. This might include analyzing the structure of the web page, any URLs, or detect fake login pages. Next, it would be the visual element analysis. Visual element analysis is any pictures, any videos included within the website. So the headless browser can render the phishing site and then capture the screenshots. Computer vision would analyze these screenshots. It would search for objects, detections, and then it would do visual analysis of the algorithms, logos, and will match that these things will match the original website. Final stage is which will compare them to the legitimate website itself. So a headless browser will access the legitimate website just similar to the way it would access the malicious one, and then the computer vision would perform the same thing. Okay, so now coming to the actually using AI to automate the validation of phishing sites. We will be using one of these APIs. All of them almost provide the same functionality, whether you're using the Azure AI services or the Microsoft one or the Google Cloud Vision API. We're going to use them in a combination with Deep AI, which will capture screenshots for the malicious and the legitimate website, and the headless browser, as we discussed. Okay, so here's the breakdown of the script itself. So the script will be using a URL string or a web page content as an input. So for instance, the DHL page we've shown earlier on, we can give it just the URL link to the headless browser, to the script, and then the cipher bot, which is the script developed for this, will extract these features, compare them with many anchors of the website itself, and then it will use AI vision and compares the 2 images and makes a decision. Okay, now we're going to get a little bit technical by viewing the code. At first, viewing the code, we want to set the headless browser so it would take the image or the content of the page and bring it to this code for further analysis. And then we will capture the screenshot. So as you can see in the first segment, we will capture the screenshots. We will initiate the headless browser, and then it will take the screenshots. It will save it in a variable. Next, we will perform any logo detection. It will check for any logos within the website, and then it will create an image object, perform a logo detection, and then print the detected logos if any. This detected logo will be found from the database that the AI will use. And then here we have the content analysis function. It will search through HTML content of the web page that has been brought by the headless browser. It will perform content analysis by checking for login forms, it will check for suspicious URLs, and then check for any JavaScripts that seem suspicious uh, to be there. And then it will check for also meta tags for any inconsistencies we will see. And finally, it will check for iframes if there is any suspicious iframes existing within the URL. Finally, it will take these two screenshots of the pages and then they will compare them using deep AI. And then it will give a similarity score at the end. Okay, what are the results of running this script? So the script has used the legitimate URL on the right, which is for Netflix, and then the potentially malicious one over here. So initially we've given the script the URL for the malicious sites, and then it has came back with the results of the following. It says potential phishing. It has detected a login form, potential phishing, suspicious URL, and then it has also detected an iframe. And then it gave two scores, which is one for the logo and then one for the image similarity. For the logo one, it has identified that the website belongs to Netflix, and it gave it a score of 0.9. Image similarity, it has compared the two images and then also gave it a score of 30. What does this score mean? First, for the logo part. For the logo parts, the API used from the Google Cloud, it will use a score ranging from 1 to 0, where 1 indicates a really high or confirmed potential impersonating attempt, and 0 would indicate a low one. These results could be adjusted based on your analysis. You can set the score for it to be otherwise, other than 0 and 1. You can say that if it goes up to 1, you can have if it goes up to 1, meaning otherwise, and vice versa. The image similarity score that was using from Deep AI API would indicate a lower distance value indicates a higher similarity, and a higher distance value indicates a lower similarity. In this case, it gave us a 30, a lower one, which means a high similarity potential. Okay, coming to the end of this session, what I want to highlight is the script that was written. The script that was written in here is not the most accurate, it's not the most efficient. It was written for the purpose of this session only. What I want to say is you can explore API in different ways and you can generate different models. You can have your own models, you can train them and to be better and more efficient than this one. You can set the scores on your own and you can explore using AI in different ways. Also, I want to highlight that you should consider any legal and ethical considerations when doing so. You want to be careful when using APIs, when sharing APIs with other users and putting them in public repositories. And also you should consider any organization policies that might suspend using API or allowing you to scan through their websites. This brings me to the end of this workshop. Thank you so much for attending and listening. Please, I would really appreciate if you could give us your feedback through scanning this barcode.
Yes, merci.
والله